Welcome to the ET322 how-to video for the Clipper Clamper homework. In order to do this problem, we need to figure out what the voltage divider is with the resistor in parallel with our diode. So we're going to use the voltage divider formula. So it's V times the load over the load plus R1. So we have 6 volts times 5K divided by 6K, which is 1 plus the 5 equals 5 volts. Alright, so when this is positive, our diode is reverse biased, so it's going to be 5 volts. When it goes to the minus alternation, the diode is forward biased, so we're going to be locked in at our nominal value, 0.7. Okay, here we just have a rectifier circuit. And we have 8 volts peak to peak. So what's going to happen is we're going to get a voltage on here peak to peak. So what we're going to do is we have what? 4 volts peak, and we're going to minus a 0.7 for our diode. So we're going to get a 3.3. And we're going to be here at 0. Okay, so we have to start and figure out what our load resistor value is for voltage. And we have a voltage of 12. There we go. 12 volts times 10K over 10K plus 2K. And if you notice, I've made it easy for you, since 2 and 10 equals 12, so it's just going to be 10 volts. So we have 10 volts, and we need to figure out what our diode is. So when it's forward bias, we're going to get the 0.7 and 3 volts. So we're going to get 3.7 volts is what our diode will be locked in when it's positive. So we're going to be clipped 3.7 volts, and we're going to get a minus 10 volt on the bottom. Okay, first thing we need to do is add the 5K that I lost somewhere or another. Okay, so we have our voltage divider. Since these are identical, it's going to be half of the 10 volts. So we have 5 volts on our diode, our resistor here. Now we need to figure out what voltage we have on our diode here on the resistor. This is also another voltage divider. So we're interested in what's going to ground. So we have 3K over 5K plus 3K times minus 8 volts, which is 3 volts, minus 3 volts. And we have a diode of going in the other direction, so we're going to add another minus 7.7. So we have here minus 3.7, and when this is positive, it is going to max out at our locking voltage, which is 5 volts. This one, when it's reverse biased, it's going to be minus 3.7, clipped at 3.7. Good. Okay, so what we have here is a clamper circuit. And once this is positive, our capacitor is going to charge to 12 volts. And it's going to get locked in of 12 minus 0.7, which equals 11.3. So I'm going to just change our diagram here, and I'm going to make this 11.3 volts. And this guy is going to dip in to minus a diode value, 0.7 volts. Okay.